Rootstock is an amazing layer 2 blockchain that brings Ethereum smart contracts to Bitcoin. And in this video, I will teach you to write a smart contract in Solidity with tests, deploy and interact with it using hard scripts and ethers.js. I'll walk you through every step from creating a contract to deploying it on the testnet. Let's build. What is Rootstock? Rootstock is a very interesting chain. It is a layer 2 EVM compatible chain, which means it brings the Ethereum capabilities and then sits it on the Bitcoin layer. So with Rootstock, you can build and deploy smart contracts just like how every other Ethereum chain is. But now it comes with something interesting. All that is being done on the Bitcoin layer, which is a very strong security layer. As we can see on the website, which is rootstock.io, we can see lots of interesting features about the chain, unlocking the Bitcoin DeFi layer, building DAOs and whatnot. Lots of developers are currently building dApps on this chain because it offers a strong security, it offers lots of opportunities, and it offers, aside just smart contract capabilities, the community is a very good one. There's the Discord, there's the documentation, and there are lots and lots of things to explore on the Rootstock chain. Compared to Ethereum, Rootstock offers some benefits to developers building on Rootstock. Some are low gas fees. Now, this means that you spend relatively low to execute transactions on Rootstock. RBTC, this is the native token of the Rootstock chain, and it is pegged to the Bitcoin. This means there is less fluctuation in gas price compared to it. Also, there's low latency. This means the transactions on Rootstock are very fast. It has faster transaction speed. That is why you have to explore and build a Rootstock chain. In this tutorial, we're going to build a dummy token contract. This is a very simplified form of a token contract, which allow users send sort of value, digital value, would allow them mint, would allow them do some basic functions. And then we're also going to test the contract. We're going to test this contract in a hard hat environment. After testing this contract, we're going to deploy this contract to the Rootstock testnet. Now, after deploying this, we're going to interact with the deployed contracts using ethers.js. Now, this is a very interesting thing, and all this will be done in a beginner-friendly manner. Now, since this is a highly beginner-friendly video tutorial, the prerequisites are very simple. All you need to be able to follow up with this tutorial is installation of all these listed. We must have installed Node.js, that's the JavaScript runtime. We must have npm, that's Node Package Manager, or whatever package manager, npm, yarn, or pn. So these are any of the package manager options are valid. Then a code editor. So I use VS Code, as you can see, but then any other code editor option is fine, which is like Sublime, whatever code editor. I don't really know much, but VS Code is my way. So also you must have installed Git and GitHub. So these are basically the requirements. To check if these have been installed, just head over to your terminal and do for Node.js node ---- version. For npm, same thing. For Git, the same thing. So if these happen to throw an error on your device, just head over to go to your browser. You can search for nodejs.org and then you should be able to download the engine and install it. They have a good documentation. Then for Git too, depending on the type of device you're using, if it's a Mac, if it's a Windows or a Linux, then you should select your desired option. Now, if you haven't installed this, please go ahead and pause the video and install these softwares. See you on the inside. And if you have already installed all these, let's dive straight into it. To get started writing smart contracts, there are different tools to use. You can use Foundry, we can use Remix, and we can use Hardhat. Most of this video tutorial, we're going to be using Hardhat, and there are different ways to install Hardhat. You can check out the documentation, hard hats, getting started with hard hats. Yeah, lots of interesting ways. But here's something interesting. Rootstock has something called the hard hat starter kit. This is a bundle of packages and boilerplate code that would help a beginner, would really supercharge your coding when you're starting out writing smart contracts. All we're going to do is come here, copy the git, and then clone it on your machine. For the purpose of this tutorial, I have beforehand cloned this, but for you, all you need to do is git clone, and then it's going to clone to your device, and then next you're going to do npm install. That should install all the necessary packages. Now when you install it, let's open it in your terminal. Open the VS Code or whatever code editor you're using, and you should see something like this. The folder structure of the project should be like this. Now, let's go over the most important folders here. We have the contracts. So here are some dummy contracts that came with the starter kits. For us, we're going to be writing most of our contracts inside here, and then the deploy folder basically contains deployment scripts. So if we want to deploy our contract, we'll head over to this folder, create our script, and then create our file and write our script in it. And we have the node modules here. Then we have harder tasks. So this harder task is basically used to automate scripting and hard hats. As beginners in this tutorial, we're not gonna do anything related to that, but it's good to just have knowledge about that. And yeah, the test file, very important. We used to write tests and to validate our contract and that it's working as it's supposed to. Another important file which we shouldn't miss is the hardhat config file. It's a very important file. It contains the configuration of the hardhat project. As you can see, the tasks are here. The RPC linkage happens here. We can see the network listed. We have local hosts. We have the mainnet. We have the testnet, then we have etherscan. So this will be used for verification of smart contracts. We're going to see that shortly. And then we have the compiler. So as you can see, all these, you don't need to write them yourself. It comes in pre-built with Rootstock hardhat starter kits. If we didn't use this route, we'd have had to write a number of things ourselves. So now what we're going to do is just edit based on what we need and whatnot. So the last one here, we have the evm.example file, which is basically what our .env file should look like. So we're going to create a .env file and paste in the content of the sample file. Now for the mainnet RPC, we do not need it, so we'll just put like a dummy text here, hello world. Then for the testnet RPC link, we can get that from Chainlink. All the links are going to be in the video description, so don't worry. Now, from not Chainlink, chain lists, you can search Rootstock, and then you should find Rootstock mainnet. Ensure that this checkbox is clicked so that you can see the Rootstock testnet and not copy the Rootstock mainnet. So you can select one of these public nodes that are, the score is good, and then all you got to do is paste it there, and then we're good to go. And then for the wallet private key, head over to your wallets. If it's a browser extension like MetaMask and Rabi, you copy the private key and paste it here. Also to note that sometimes public RPC can fail. Due to the fact that there are a lot of people, there's a lot of there can be latency too, because lots of people are trying to access the RPC at the same time. One good thing to do is head over to Alchemy or Infura. I use Alchemy, so you can also use Infura. These are like node infrastructures that would provide your specific RPC link that won't be crowded. Yep. So I already have my app created. If this is your first time using Alchemy, you have to create a new app and go through the creation process. But since I already have mine set up, I'll just click and then go to the network tab. Now, Rootstock is one of the supported networks. Once you search Rootstock, it's there already, and then you switch to testnets, and then you copy this RPC URL that's been copied here. works as this. The only difference is that the one you get from Alchemy is not public. That's the basic difference. Now that we have an understanding of the starter kit structure, and then we have the setup done, let's dive into writing smart contract. Now let's do a little planning before jumping straight to writing Solidity. So the dummy contract is going to have some state variables. Now, state variables are basically things that we like to store, keep record of. Now we have balances. This is store like the balance of addresses in the contract. Then we like to also store the owner of the contract. Now, aside these two state variables, the contract is also going to have functions. Now, as you can see, the state variables are very basic and not so much. So depending on the complexity of your smart contract, the state variables can increase. Now, the functions we're gonna have mint. Let's call it mint dummy. So this mint dummy contract would be the function that will be used to mint the token, and then another function called transfer dummy. So this will be used to transfer the token. Now, this is an overview of what we're going to be doing in the Solidity file. So let's jump over to, we create the file. Let's call it dummy.so. And let me see the Solidity version for this. Okay, it uses this. So we can just copy this and paste it here. So this is the SPDS license identifier, which is like for every Solidity file. It identifies the license, and then pragma solidity 0.8.24. So pragma is just like a keyword that tells the Solidity compiler that specifies the version of Solidity which has been written in the file. But it's kind of like there are so many versions of Solidity. So, but with the pragma keyword, the compiler already knows the version of Solidity it's compiling. So now we go direct to, we'll say, contracts, dummy token. So let's start by creating the balances. So we can easily do that with mapping. So it's going to be a mapping of addresses to uint 256, and we call it balances. Also, we're also storing the address, and this is going to be public of owner. Now we can see that the balances is not public. We could actually do that to be public, so let's make it public. Yep. So public simply means it is accessible by all. Now let's have a constructor, and what this constructor is going to do is that we're going to set the owner to msg.sender. Now what constructor does, or what a constructor is that a constructor is what happens immediately the contract is deployed. So the process of deployment is such that once the whole Solidity file is compiled into something called bytecode, it is deployed. And after deployment, there are certain things we want to do by default, like setting the owner of a contract, doing whatever, like certain configurational type of things which we want to do. So all this can be done inside the constructor. Now msg.sender is simply referring to the person that deployed the contract. Now let's move on to mint dummy. So we can have, let's define a function, and let's call it mint dummy, and then it's going to receive as parameter an amount, and then an address, call it the to address, and then it's going to be external. Okay, so what is going to happen in here is, firstly, we don't want a person to transfer 0, so we're going to require, and what are we requiring? We're requiring that the amount is not equal to 0. So, and if it's 0, we will say cannot mint 0. So this require is enforcing the condition. If it require amount not equal to 0, that means this condition will only pass if amount is not equal to 0. If amount is 0, then it's going to throw this error. Sometimes require can be confusing. Yep. And instead of using require, which is just like a one-liner, we can also use something called revert. So you can say if amount equal to 0, then you can use revert. Yes. So this line 13 and line 14 to 16 does basically the same thing. And then within revert, you can also put the text which you want to like display. All right, so since the user cannot mint 0, what we're going to basically do here is update balances of the two address to amounts. Now, minting is sort of like bringing something out of the air, just like how, countries or governments of countries in currencies. That money that is being printed is it's coming out of nowhere and it's coming out of thin air. So that's the same thing that's happening here. We're just adding the amount to the balances. That's that about mint. And now for transfer. Now transfer is sort of different from mint. What transfer does, it works with what is currently in circulation. Just like how, when a person A wants to transfer some money to person B, the person is basically transferring what is in his account to the next person. And when you transfer, there are some things you want to happen. Number one, you want to ensure that the person that wants to transfer has the amount. Yep. So you want to ensure that the person has the amount. Then you also want to ensure that the amount is deducted from balance. So when the transfer happens, you want to deduct, or you can deduct the amount before the transfer happens. So that will be amount. We have address 2. Then we can call this external 2. So a person who is the MSG sender in this case wants to transfer amount to an address called address 2. So firstly, we need to check, okay, we need to require the same statement here. Amount is not 0. Another thing we can require is want to ensure that the to address is not the MSG sender. That means we're preventing a person from sending to himself, so invalid requests. Another thing we want to ensure is that the balance of the sender is more than the amount that is being sent. So once we require that balances of the MSG sender, who is the person that is calling the function, is greater than or equal to amounts. So if not, you can say insufficient. And now what we can do is basically deduct the amount being sent from the sender's account, then updates the balances of the receiver. And boom, we have the mint dummy and the transfer dummy function all set. So another thing that can be added are events. So we can add events. I can say events minted successfully. And when the minting happens, we can use the keyword emit minted successfully. And then for transfer dummy, we can also say events transferred successfully. So when it's completed, we can use emit transferred successfully. So events are basically ways used in smart contract to emit, to show that a certain event has happened or a certain transaction was done. It's sort of like a way of announcing publicly. Most of this data that is like most of what is happening inside this function is happening inside. But how do external bodies know that, okay, this happened? Now, these events are not receiving any data. So the best way to do is, passing some data like, okay, 256 amounts, and we can say address 2. So this way, we're basically saying we want to emit the minted successful event with the amount that was minted and then the to address. So this way, if there are any oracles or if there are any servers that are listening to the contracts, once the mint function is fired, this event is going to be emitted with the amount and then the to address. So we can just pass in amount and then to address. And then the same thing goes for the transfer successfully. So we can pass in the unit 256 amounts, also pass in the sender and address 2. We'll pass in amount msg.sender and then the to address. So now that we're done with this, the next thing to do is to compile. So we'll move to this, okay, here. Okay, yep. So we use npx hard compile, and let's watch it compile. If there are any errors in the compilation process, this is going to like cool. So we have no errors. That means our contract is all good. There are no syntax errors. Everything is all clear. And yep. Okay, one more thing to add. It's called modifiers. So a modifier is a function that when defined can be attached. They are sort of like function decorators. So for instance, let's look at this. So this modifier is called only owner, and it's basically used to lock a function such that only the owner of the contract can access that function. I say only owner. Okay, it has like its own, yep, can put a column here. Okay, so let's say we like purposefully do this and we try to compile, see how this works. You can say npx hard hat compile. Yeah, so it says expect this. Yep. So Terry tells us what the error is. So you don't have to be scared of, being perfect. The compiler is here to help. Once we compile again, yep, successful. Modifiers are basically function decorators that enforce a particular rule set or set of rules defined within the modifier. Now we define the rule here that only the owner, it checks who the caller of the function is and then enforces this condition. So we would want to add that to the main function. Why? Because the main function can be can be misused many times. We're not looking at, like, basically is not necessarily a real world use case. It's just a dummy token, but we're just trying to, explore and touch different concepts. So if we, put the only owner function here, we're trying to only owner modifier here, we're trying to enforce the fact that this function must only be accessed by the owner of the contract. So let's compile and let's see what happens. Cool, so it compiles. So in future, when we're calling this function, we only expect the owner of the function to successfully call this function. Next up, we're going to write tests to see how exactly these things would work. Okay, guys. So to start writing tests for the smart contract, come into the test folder and you create a file, name it whatever, but in our case here we use dummy test.ts, and just like other dummy test files or sample test files that we have here. And then right in our test, I've written this boilerplate that we're going to use. So firstly, on the first line, we import expect from chai. So chai is a package which provides functions like the expect, which you're going to use while testing. Then we import deployment, ithars, and get named accounts from Hadat. So ithars here, it's a very important library which we use to interact with contracts. And we're going to still use ithars when we are, after deploying the smart contract, when integrating or like interacting rather, when interacting with the smart contracts. Then get named accounts. So this would be like, it's sort of like gives us an array of accounts or signers which we can use to interact with the smart contracts. All right, so all the test is going to be written within the test suite. So when writing tests, we have a general test suite, and this test suite has a name. So we call it dummy token. So within the test suite, we are now going to have quite a number of things. So within the test suite, we're going to have like a setup. This setup is it's basically creates, it deploys on tests, the smart contracts, which we're going to be testing, and then it does whatever configurations that need to be done. For instance, like the constructors and whatever things need to be passed into the contract when it's being deployed. So that's what this setup does. And then we will also have other test suites inside the general test suite. So think of it like this. We have a general test suite called the domain token, and within this test suite, we're also going to have like smaller tests. So now within the test, then we're now going to have like the it. So it is basically used to enforce a particular set of rules. For instance, now this it will have, it should set owner. So within every test suite, we're going to have some set of it's. So that is basically how the test goes. It's sort of like repetitional, but then once you get the idea once, it just sticks. So now let's start from here. We have the setup fixture, and then we use deployments dot create fixture to like create this whole thing. And now what we're gonna do is, what we did rather here was we get the signers. So signers, like I said earlier, is an array of accounts which will be used to like interact with smart contracts. And the next line we did dummy token contract, set it to ethers.deploy contracts. Usually without this, what would have happened was we're going to deploy this contract and then interacting with the contract would be like testing it. But what happens here is that Ethers runs like a test deployment, which is actually fake for the purpose of testing, deploys the contract. Now, at the next line, we're now returning the deployed smart contract, which is the dummy token contract, returning the address, returning the deployer, also returning the account. So now the dummy contracts is what we're going to be using to invoke the functions in the functions of the contract. Then the deployer to be used, which is like the owner. So we're also going to use that. So the other things that were returned, they're not so necessary, but we might have need to like use them some other time. So now our first suite here is deployment params. Basically what we're trying to do here is we're trying to ensure that the parameters in this constructor was correctly set. So here in the constructor, we have owner is equal to a message of sender. That means we're ensuring that within the test here, we're trying to check that the owner was correctly set. And how do we do that? So firstly, I'm going to comment this line. Now, this setup fixture is a block of code that can be reused within every test setup, within every test suite. So here we await the setup. So it's asynchronous, so we're awaiting the setup. And what it does is it returns this it returns these variables to us, destructure it and call it. So the rule of thumb here is we have the domain token contract. Now the domain token contract has some functions. Here we have the mint dummy token, the transfer dummy function. Those are the two functions that are particularly obvious. Well, now if you look very well at these public state variables, they are also functions. So that means balances is a function and then owner is a function. This is because they are public. What happens in Solidity is that once you declare state variables as public, Solidity by itself creates a getter function that can be called. So that's what we're trying to do here. We're doing await domain token contract dot owner. So this is the getter function that returns the owner. And then the dot to dot equal. This checks or compares what is returned here with the deployer. All right, so to run the test case, we are going to do npx hard hats tests. Hey, so looking at this, we see that this runs quite a number of tests, and we can see if you look very well, domain token. Let me increase this. Okay, this is not allowing me to increase. But if you look at our dummy token test suite here, it passes. But now these other tests that are failing are not part of what we wrote. So what we're going to do here is we're going to fine tune this command to only run the exact tests that we want. Yes, tests slash dummy tests. Yes, cool. So this is the command that we're going to use moving forward because it focuses on the file that we're working with and leaves out the other things there. In the case where you're working on like many contracts and you're writing different test cases, you don't want to just, do npx harder tests and then run all the tests. So you want to isolate each test case. So now our test passes. So that means it correctly sets the owner contract. So what's another thing we can check? Let's go back to the contracts. So that's majorly the only deployment parameter that we have. So let's move on to the mint dummy function and then the transfer dummy function. All right, guys, so we're going to be testing the main dummy function. And to do that, firstly, we're going to create its suite by just copying and pasting that, and then rename this to be main dummy. And now we can comment this out. Sorry, not that. We can comment this out. And then instead of should set owner, the rule set that we're going to define here is dependent on what is in the function. So we look at the function means dummy. It accepts amount and address, and it can only be called by the owner. Okay, So one of the rule set is amount cannot be zero. And then another condition, not condition, but functionality here is that it observes the balance. So there are two types of testing. There is a test for positivity and then a test for negativity. So when we're testing conditions, we can test that we're expecting a condition to fail. So we're expecting the function call to fail if the condition is not met. That's a test for, that's a negativity test. And then the positivity test is testing that, okay, functionality works as it's supposed to work. We're going to test for negativity first here, and we're trying to test that the amount, that is a zero amount, cannot be minted. So we'll go here, say prevent maintain zero tokens. All right, so we also do the same thing. We await setup fixture. Let's uncomment this. Okay, so here, since we're expecting it to fail, right, we are not going to be using the dot two dot equal, right? And then we're not going to be calling the owner function. So we're going to be calling the mint dummy function. Yeah, and the mint dummy function accepts the amount and then the address. Okay, so we need to create an amount. First amount equals, we use the ether library, then we call the pass units. So pass units creates a begin from a string value. So we pass in 0 because we want to pass in an amount which is 0, and then the decimals which is 18, because the assumption that we made when writing a contract was that it's a token of 18 decimal, like decimal is 18. So aside this, we also need the receiver address. And remember earlier I said accounts is an array of accounts or signers. So we just, accounts, and then we pick anyone. You could pick 0, you could pick 1. So we pick the 0 index, which is signer at the 0 index. And now this is basically a signer. It had that if a signer. But what we're passing in here is an address. So we call the function or the attributes or property address. Now we pass the amount, and then we pass the receiver into the function, and then we do dot two dot reverted with. That's because we're expecting an error. And now, since we're using dot two dot reverted with, we're supposed to pass in the reason. The reason must be the same as this. Okay, so let's go back and paste it. If we put in a reason other than this, it would fail. We're going to test that case too. So now we do dot two dot reverted with. Now there's an error here, but I want us to fix it together. So I purposely made the error. So we're going to tinker it together, because many times the test cases will fail due to one or the other reason. So let's run this, and then it fails, and the reason was VM exception while processing transaction. So one of the reasons could be the fact that we didn't have a dot B here, because when we're reverting, we're supposed to add dot B. So let's see if that fixes it. Okay, so we run. So it still fails. And one of the reasons why it fails is because we are not supposed to await. So when we're expecting the function call to fail, we're not supposed to await. Await should be outside the expect block, not within. So when we're using, remember when we were trying to get, so above here, when we're trying to get the owner, because the owner is a property, it has a definite value, is a promise that will be resolved into a value. So we use the await within the expect block. Now the await here inside the expect block is useless because we can await a failure. Yes, so that's the best way I could put it. So let's try running this and see if it works. Okay, it works. So don't make the mistake of awaiting the failure or putting the await within the expect. So the await is meant to be outside the expect. Beginners make this mistake a lot, but then I made this intentionally so we could fix it, and then when next you're having errors while writing tests, you don't panic, you just see through it. All right, so now we've tested for negativity. Let's test for positivity, which is we're trying to test that when the main function is called and when it goes through successfully, the balance of the two address increases. All right, so this is gonna be we're gonna call number of functions. Okay, so let's first have the each block ready so we could it's basically same as this. Like I said earlier, testing is just it's repetitive. So we just need to edit certain things. So the block here is main token successfully. That's going to be our line here. And as you can see here, when we call the tests, we see the deploy, we see the what do I call this again? We see the test suite, the name of the test suite, and then its statements that were written under it. Okay, so we have mint token successful. And now we're not going to mint 0. We're going to mint 10. So now instead of minting 10, so okay, we're minting 10 and then we'll have the receiver's address. Oh, what are we expecting? How do we do the expect here? Okay, so we are expecting so now there is no need to expect this. What we're just going to do is we're going to call this outside the expect block and we're going to await the result here. I'm going to explain that. So what we're expecting now is we're expecting that the balances of the two address increases by amount. All right. So what we're going to do here is we're going to call the balances function. So the balances is public here, so it has a getter function. So we're going to do instead of await being outside here, it's going to be inside dummy token contract dot balances. Good. And now we're going to pass in the receiver. Okay, so it's not going to be reverted with because we're not expecting a failure. Rather, we can do, okay, dot equal. So because the balance of the receiver here is 0, we can say dot equal. So when we say dot equal, that means it should be equal to the amount. So now let me go over this again. We pass the amount, which is 10. We define the receiver. We call the mint dummy function and we await it. So that means it's going to go through successfully. But now the evidence that this function was successfully mined on the blockchain is when we test that, okay, the address which the token was minted to, the balance of that address now equals the amount which was minted, which is the 10 here. So now that is basically what we're testing here. So we're going to run the test again and let's see what we get. So it passes, that means it works as expected. Now, another thing we can test that, okay, I just remembered earlier that I said if you don't put the exact revert string, it's going to like fail. So if we delete the 0 here and let's run this again, we'll see that something would fail. Okay, yep. So we can see that the prevent maintain 0 tokens each case fails. So that's what happens when you don't use the exact revert string. So you could be writing your test case and then your code works well, but because that revert string doesn't match what exactly you placed in the contract, so that's why you keep getting errors. So ensure that your eyes are really open for that. All right, so one more thing we can test within the mint dummy context is the fact that, okay, so this can only be called by the owner. So we want to test that this function can only be called by the owner. All right, so we're going to, murder test case again is repetitive. I mean, mint token can only be called by the owner. All right, so we're going to do amount, we're going to do receiver. But now, so by default, when you're writing test cases, default connected signer, that means the signer that is calling the mint dummy function or any function that you write within the cases here is the deployer. Okay, so but the only way we can change this is to do a dot connect. We can do a dot connect. Okay, connect doesn't exist. Okay, so the dot connect doesn't exist on the mint dummy function, so that's the wrong way to do it. I'm currently connect a different signer. We have to attach the dot connect to the contract itself. Firstly, we can see it here dot connect, so it exists here, not on the mint dummy. So yep. So now we're going to cut this out of here, and then because we are testing for negativity here, so the await is not going to be inside where you don't have any business with balances. Our main business is with the mint dummy function. And now remember, the await is supposed to be outside and not inside the expect block. So we're going to do .2.b.reverted with .2.b.reverted with, and then what's going to be the reason. So if we go back to our contract, we see that the main domain is only owner modifier was what defined, the behavior of restricting the function to only the owner. And if we go to the only owner function, the reason here is only owner. So we copy that and then we paste it as the reason here, only owner. So, but here we have not connected a different signer. So we're going to connect account and we're going to do accounts, let's say of index one, and then that's going to connect a different signer that we don't even know about. Okay, so let's try running this and see. Okay, so we run this. All right, so it passes and see means token can only be called by the owner, and see it reverts. Okay, right. So that's how we test the mint domain function, and we can also do the same for the transfer domain function. So the transfer domain function has three cases where amounts, we cannot transfer zero amount. We can send to the sender. So imagine a sender wants to transfer to himself the same amount. So that's also going to fail. And then we have insufficient balance where a sender is trying to send what he doesn't have. Okay, so let's see if we can quickly set that up. Okay, so we copy this, and so this part of the video would be made. You could actually just put a video on 2x or skip because it's basically the same idea. Like I said earlier, um test cases, writing tests is kind of repetitive. It's just, the syntax is very repetitive. It's just, seeing different scenarios and cases and trying to like see how things work out. Okay, so our first case here is cannot mean zero, and I think we cannot transfer zero. So we could do that. Cannot transfer zero. And then the transfer function accepts amount and to address. So that's basically just like the mint. So we're going to copy this here and we'll paste it here. So we have the amount and the receiver now. So we're going to call dot transfer here, transfer domain. And then we're going to pass the amount and also the receiver. Okay, let's not make the same mistake. Our weight is going to be outside and then .2.b reverted with. Okay, so what's the reason? That's the reason. Okay, I guess this was a typo. Cannot mint zero. It's supposed to be cannot transfer zero. Okay, so you could fix that because if you fix this here, we'll have to redeploy. Okay, so we can actually do that. So let's do cannot transfer zero. Okay, so when we do that, all we just need to do is we need to recompile. So npx hard at compile. So you can see as we're testing, we're figuring out errors in our contracts. And without this, imagine we had just deployed contracts. That error is there already, and I mean it has been made already. So when we do npx hard at compile, I mean this is already fixed. So we'll just copy this and paste it here as the reason. That should fix it. Okay, so we run, and sorry, not this. We have this. Okay, npx hard tests, so it passes. Great. So another thing we want to test for is the invalid requests. So we want to make the case where the to address and the message is saying that the same. So we can still copy this same test case, but just tweak the parameters. So cannot send to sender. Okay, so the receiver here is going to be the deployer. So we just change this to deployer. And now I think the deployer is okay. So the deployer should be an address. Let me see. Okay, the deployer is an address. Okay, so we'll do transfer domain dot receiver. Okay, instead of doing 0, let's do 10 because we don't want the earlier case to affect this new case. So we test the case, we test the scenario, then we kind of reshuffle the conditions or the parameters. So it's going to like, we're trying to walk through a scenario. All right, so the amount is no longer 0, but then the receiver is the deployer. And what do we expect? Cannot transfer 0. We expect to get an invalid request error. Okay, so I'll paste that. Okay, so let's run this and let's see. All right, good. It passes. Now the next thing we want to test for is want to test the negativity here. That is the balance AA. The person is trying to send an amount that he doesn't have. So so we copy this and we paste again. All right, so we want instead of deployer now, because if we leave the deployer like this, it's still going to fail. Okay, so we're going to pass that constraint. That means we're going to ensure that the receiver is not the deployer. So testing is all about creating scenarios in your head and playing them out. And now that the receiver is not the deployer, we're going to say, okay, it's trying to send an amount which is 1,000 of the tokens. But let's think about this. Deployer doesn't have any token, but then he's trying to send 1,000 tokens to a receiver. Remember, we don't have like a dot connect here. The person, the default runner of this function is the deployer, but the deployer doesn't have any token. So we expect this to fail with insufficient balance. Okay, so let's paste this. So what's the correct way this is supposed to work is the deployer is supposed to mint some tokens to his account. After minting, then transfers. Okay, so that's the right way. Or it mints to the receiver and then the receiver then transfers. But the way it is, it doesn't have any token at all. So let's call this, okay, let's edit this. Cannot send tokens more than balance. Okay, so we expect this case to fail. Okay, so this is expected transaction to be rewarded with insufficient balance, but it rewarded with invalid request, and that is the last one. Okay, so let's look at this. Look at this. Okay, so we're passing amount to the receiver. So we just have to look deep into this. Accounts. Okay, let's see if we use instead of 0, let's use 1. We didn't connect here. Okay, so this passes. This passes. All right, great. So we use account 1 instead of account 0. That means the account 0 is the deployer. So the 0th account is the deployer's account. All right, so since that passes, now we have tested all of these 3 conditions. Now let's test this remaining 2, which is when a transfer is successfully done, the sender's balance should decrease and then the receiver's balance should increase. We're going to test that in one function. And yep, so let's write this. And the block should just be, it should transfer successfully. But that's what makes a successful transfer, deducting from the sender and crediting the receiver. So here, we're not going to call this transfer domain inside here anymore. We're going to call it outside. But remember, before we transfer, we need to mint. So we're going to bring in our mint. We're going to bring in the mint here. So it should mint successfully. We're going to bring in the mint. So what we're going to do is we're going to say amount.mint dummy, yes. And now the receiver now is not going to be this. The receiver is going to be the deployer. Okay. So that means we're first minting. And now after minting, we're not going to call the transfer. So await not transfer. But now we're now going to transfer amounts. We're going to transfer amounts to the receiver rate. All right. So what are we expecting? Now we're expecting 2 things. We're expecting the balances, okay? So await dummy double contract balances, the balance of the deployer. So we're expecting the balance to be what? 0, because now the amount he minted, the amount the deployer minted was 1,000, and then he transferred all that token to the receiver. Okay, so we're expecting dot two dot equal, and it should be 0. And then now we're expecting that the balance of the receiver. So we're gonna do dummy contract dot balances of the receiver. Now dot two dot equal, and now it should be equal to amounts. So basically the sender's balance goes to 0 and then the receiver balance increases as the last test. All right, so let's see how that goes. Great, so that works. And now we're done testing for smart contracts. So based on how complex your smart contract logic is, that will determine how complex your test cases is going to be. So now we just have three test suites within the main test suite here. and yeah, we did it. So in the next section, we're going to talk about deployments. Okay, we're going to deploy our dummy smart contract, dummy token smart contract. So go into the deploy directory, create the file deploy dummy.tx, and it basically follows the format of these. Okay, so this came with, like, with the starter kit setup. So we're just gonna copy this, and then okay, the most important thing happening here is the deploy function and then the tags. Okay, so the deploy function, we're importing the named accounts, which is are the accounts, like the accounts we added to the Hadat config. Is so we're basically importing it here, and then we're calling the deployments.deploy function and passing in name of the contract. Okay, so if you look into this mock ERC20 contract, we're going to see that it accepts 4 parameters at the constructor. So we have the initial supply names, ball, and initial owner here, and we can see that here. So the arguments 1, 2, 3, 4, and then we're also passing in the deployer, and then the logs are like when you run the development scripts, the logs that show on the console. So for us here, they're not constructors, so we just clear the arguments. We don't need this. So all we need to do is change this and put in the name. Okay, so and then the tag. So the tag here is gonna be what? Let's see, dummy. Let's say dummy, yeah. So now if we want to deploy our smart contract, let's head over to RSA. So we'll go to the documentation where we the documentation on the GitHub where we cloned the whole project from. So if we want to deploy, okay, so we see HH deploy network RSK, then the tag. Okay, so we can do that. So let's see. Instead of HH, we can also use hard hat. So let's say PX hard hats, and then deploy, then the network RSK test and test nets. Now the tag here is very important. That's what brings us here. So our target is dummy. So instead of what was here, 7 to 1, we're going to do dash dash tags, and it's going to be dummy. And so press enter and see, which is deploying. And when we set the log through this that we're seeing on the console, so we just give it a little time to mine the transaction on the blockchain. And depending on your internet connection, this might take time. All right, great. So as we can see, deployed at this now, and it shows us the amount of gas. Great, very, very cool. So we'll go to Rootstock testnet. So this is it. Rootstock testnet of block scouts. Don't worry, this links will be um in the description. So what we deploy to remember our script, we reference the RSK testnet. So the contract is deployed here. So if we paste the address, we can see it here. And now the problem is that we cannot see our code here. We only see the transaction here. We cannot see the code. So we see contract creation and see this is the deployer's address. But now we cannot see the contract, and that takes us to verification. So how do we verify the contract? All right. So we can see here from the documentation, npx highlight verify network, and then so we do npx, let's tell it npx hard to verify, then the network as RSK testnet, and then we paste the contract address, which was this that we copied. So if the if you had like constructor arguments, you'd have passed them like in form of a string. All right. So we press enter. We give it some time. It's a successfully verified contract. So now if we open this, okay, so I'm gonna copy this and I'm gonna paste it here. So we can just come here and we can see it's showing bytecode. And this is, we loaded this browser before the verification. All we just have to do is like reload the browser, could copy and paste, same thing. And now we can see the contract has like a green tick, which means it's been verified. And boom, we can see the contract code before, where it just showing the bytecode. And that is basically how you deploy and verify smart contracts with stock testnet. Alright guys, here we're going to be interacting with deployed smart contracts, and We're using Ethers for this. And as we're interacting with the smart contracts that have been deployed on Rootstock testnet, we're going to be seeing it live as we're running the transactions. We're going to see how it's updated here. So right now, the only transaction that we have on like the Rootstock Explorer and smart contract here is a contract creation, and how we can see it is by clicking like the transactions tab here. All right, so let's go into a code editor, and yep, so you create scripts folder at the root of the project. Then you create a file, whatever, TypeScript file, and then to save time, I just laid this boilerplate here. So it's basically a function with some catch. I'm catching that here, and then inside the function, so before explain the function, we imported ethers from Hardats, and just ignore the red line. I don't know, for some reason, probably is the type chain or whatever. There's like an issue here. The code still would work, but due to like the type chain and whatnot of Hardats and the project setup, it's kind of like misinterpreting some things. So here we just define like constant, which will represent the dummy contract address, and then this is the dummy contract. And what dummy contract is how we create it is we await ethers dot get contract at. So that's a function on ethers that creates an object, a contract object, which will represent the deployed contract. So we're trying to like create an object, an abstract object, which represents or maps to the contract that has been deployed already. And what we're passing into this function is the domain contract address. And now I left this place blank because it could either be something called an ABI or contract name. Now, an ABI simply stands for Application Binary Interface. And in future videos, we're going to be using that more often. But here in this case, because we deploy the contract within this project. So when you deploy a contract using a Hardhat project, the artifacts are stored in Hardhat. So we can just basically reference the contract by name. So this is dummy token. We could just reference it here by name, and automatically Hardhat knows that we're referring to this contract. But if we're not the one who deployed the contract, we have to use the method called the ABI, and we're going to see that in future videos. Okay, so let's get the dummy contract address, which is this. We could copy it here, and then we'll paste it here. Okay, now let's try to run a read call. So we look into the contract, and then we see, okay, winner is a function. Now, interaction is almost the same as writing tests, right? And the purpose why we do interaction, probably a developer that loves scripting a lot, and you don't want to like have to click on UIs. You can just write an interaction that interact directly with the contract on chain, or let's say you are a front-end engineer and you're trying to integrate a smart contract into your decentralized applications. Interaction is like the way you kind of like you understand, or you like look around the smart contract to understand it. So when I'm doing front end, most times I write interactions because I'm trying to see and understand the behavior of a smart contract, especially when I'm not the one who wrote it. And even in cases where I deploy the contract myself, writing interaction is almost like the best way to like see the results. And since writing the interaction is in TypeScript, it gives a better idea of how the front end is going to work. So those are like instances, and you could have multiple cases also. All right. So what we're gonna do is make like a read call, and we're going to get the owner. And how do we do this? We say okay, const owner variable, and then this is going to be we're going to await. Then we're going to do now, since this domain contract is the contract object in this script, whatever functions we're going to be calling will be on the contract. So dot owner. Yep. Now let's log it to the console. And so the owner. All right. So let's test this out. And to run this script, we're going to use npx add run, and then this token.ts is inside scripts. So we're going to do scripts slash token.ts. Then we now reference the network, and the network is RSK testnet. Okay, so there's an error, and I personally didn't say anything about it because I won't talk about this. Many times when you run your interaction script for the first time, you would get this error, invalid argument, and this is simply because okay, if we look at the top, you see something called the type error, and the description is bad address sum and checksum. So what happens is it has does like a checksum to validate an address, and in this case, it happens that the way the contract was displayed on the front end and whatnot, it doesn't pass that some check. So the easiest way to fix these issues is just do it to lower case. Now this solves the issue, like converting everything to like lower case. And now if we rerun the command again, so we see the owner is this address, and then we already know that our script is working. All right, so let's do more things. Let's see. Now, let's try to main the domain again, and let's see. Similarly to how we did it in our test scripts, we define an amount. So we're doing here. Okay, let's define an amount first. Amount is we use it as ether.parse units. Now we know that if we pass in 0, it would fail because from the test that failed already. So reading the test case or writing test case already gives us a better idea of how our contracts will behave. But then we just want to write like interactions to see more. Okay, so let's say we're passing an amount and the receiver. Okay, so the receiver is, so I wrote in a dummy receiver here. Okay, and this is going to be in a string form. So let's call the mint function. Now let's say the mint transaction is gonna be, so I'll wait and call this dummy contract dot mint dummy, and now we're passing in the amount, we're passing in the receiver. Okay, now I think we should not mint to this receiver should be like who we transfer to. For this, we should mint to the deployer. So for us to get the deployer here, we're gonna do const signer equal to await ether dot get signer. All right, so this gives us like signer, and who is basically the deployer. Now the signer is like the private key, the owner of the private key that was configured in the header. All right, so let's do, so after calling the transaction, now we have to do await mint tx dot wait. Now what this basically does is it waits for the transaction to be mined on the blockchain. And once it is done, we want to log minted successfully. All right, I can spot, I think there's an error here, but I'm not trusting it. Let's just, run it and let's see what we got. So let's comment out this owner. Okay, so we clear and then let's rerun the script. Oh, great. So it ran successfully. So the token was minted successfully. And how do we test this? We could comment out this mint transaction, everything about the mint, because we don't want to mint again and again. And then we could just check the balance. Okay, so we do const balance equals await dummy contract dot balances. Now I'm getting this because I know it is balances because in our tests we saw balances right somewhere, but rather on our contract too we can see it there. So balances is there and it's public, so we know it has a function. So I'm not just bringing it out of nowhere. It's exactly what was on the contract. So now the balances would receive the address. That's the signer. So the signer. Oh, I see. We have a mistake here. So apparently we minted to, this was minted to the receiver. Wow. Okay, so what we're going to do now is we're going to mint again, but now we're going to mint to the signer. All right, let's see how that goes. I should run this again. All right, so it was minted successfully. Now the process takes time, many times because of the internet. There's so many factors. Also, it waits for, because of the wait here, it waits for the transaction to be mined on the blockchain. So that's one key thing you must know. Now we change this to signer. That means it's successfully minted to the signer. So we can comment this out and then check the balance of the signer. We can log this to the console, balance of signer. So we are going to do balance. Okay, so let's run this. Now we've commented out the meeting, so this should run very fast. Cool. So we can see this here, and we see that the balance of the signer is 1000. A lot of zeros here, and then n. Now this, if you count the zeros behind, this is like we have 18 zeros behind. That's because the decimals we put 18. So we could parse this amount using ethers has a method called ethers the format units. And then we pass in the balance and then the digit, which is 18. So this should give us 10. Suppose they should give us 10. So we rerun. Right, so this gave us 10.0. Cool. So both this and then this are the same thing. All right. So we have been able to successfully mint, through writing the script, I've been able to interact with the mint function. And the next thing for us to do is to write it, to interact with the transfer dummy function. And now what we're going to do is we're going to transfer some amount of the tokens to an address. So let's go back to this. Now we can call this balance of sign up before transfer because we're going to call the transfer function now. So let's say this is transfer. So we've got this transfer tx. It's going to be await dummy contract dot transfer dummy. And now what are we transferring? So you could transfer any amount. I mean, you could transfer 10, you could transfer 5, transfer 1. In my case, I want to transfer everything. I mean, why not just be that generous? So you transfer all the tokens to, now this is going to be our receiver in this case. So receiver. And now don't forget, by default, when we don't, remember in the test what we're writing, I said by default, the runner of the test is the deployer. The same thing is here. The runner of this script is the signer. Now the signer is basically the person, I stated this earlier, I'm going to state it again. The runner of this script is this signer. And this signer is basically the owner of the private key that is configured on the hard hat. Okay. So if you want to like change the signer, which we're going to do in later videos, we're going to have to add an extra private key and then do like a dot connect, just like how we did on the test. So you can see like both of them are very, very similar. Okay, so we have transfer tx await. Yep, so we're going to await transfer tx dot wait. And now after doing this, we want to check the balance of the signer after. So we're going to do that. We can call this balance after, right? And then we're going to also this balance of signer after. Okay. So what we can also do is we can also check the balance of the receiver before, right? We can check the balance of the receiver before. So you can say receiver balance before. Let's see before. So we're going to pass in the receiver here. And then we're also going to check the receiver's balance after. Yep, so that's correct. So we are going to log both of them. So log balance before and then receiver balance after transfer. And that's going to be receiver balance before and then receiver balance after. Right. So oh, okay, so this should be very visible. All right, okay, I'll create it again. All right, so let's see balance after something. I feel something is missing, so we have balance of signer after. Okay, balance of signer before. All right, we're not using this. Okay, so we need to put this here. Okay, so what is happening now is the current balance, according to what we checked here, was 10. That's the balance of the signer. And now we call transfer, we interact with the transfer function in between, and then we check the balance of the signer after. We're expecting that to be 0. Now we're also expecting the receiver's balance to increase from whatever it was before, which, earlier we minted like 10 to it. So we're expecting it to increase from 10 to like something else. It should be, I guess, 20. So let's run the transaction on chain now and let's hope for the best. Okay, so the balance of the signer before transfer is 10. Now the transfer transaction is, currently being mined. Great. So we can see the balance of the signer after transfer is 0.0. So basically emptied out its account because of how generous he is. And then we can see the receiver's balance increased from this. Oh, we forgot to, convert this. I mean, we already know that this should give us 10 and then it increased to 20. Okay, so, I mean, our script basically works as expected. So that is how we interact with smart contract that has been deployed. And yeah, we forgot to check on the pool so we can see this. it automatically refresh. I mean, Rootstock really, Explorer is really cool. I mean, we basically didn't even have to refresh, and then it just, we can see it. So contract creation, we can see the mint domain, we can see the mint domain when we minted again, and then we can see, the transfer, and we can see all of this. We can go to the contracts, and in case you don't want to write interaction scripts, you could just come over here, and then you could check this. Let's say, we transfer to this address. So we could just come here, paste the address here, and then, read. And then we can see the same thing that we got on the console. That's what we're getting here. Cool, isn't it? And also the owner, and see the owner's address here. And if you want to call the write function, so basically what we called here the read function, you can see it has the sign read. So if you want to call the write, we need to connect our wallet. That's basically it's very simple. This is it. It shows us the transaction. I mean, Rootstock is really, really cool. So that's very much it for this video on interactions. All right, I'll catch you guys in the conclusion. All right, guys. So we've come to the end of the video, and I just want to do a brief recap of what we did. So we started by cloning the starter kit and setting it up, and writing the smart contract, the token contract, which we first architected it, and then we went on to write tests. We went on to write tests. Writing. We explored different ways to use the test suites and then the it blocks to specify different cases within the tests. Then we went on to deploy smart contracts, exploring how to use the hard hat runtime, which is the HRE, to deploy smart contracts. And after deploying, we also checked the deploy contract on the Rootstock Explorer. And then from there, we went on to write interaction scripts where we interacted with the contract that has been deployed, invoking different functions, and then also making read calls right from our local environment here. And then we also saw the results. And then this result also, or the result of invoking those functions, reflected immediately on the Rootstock Explorer. And that's basically what we explored in this video. Want to take it further? Explore Rootstock's documentation to start building your own projects. Also, you can dive into the developer resources for hands-on support. And then feel free to join the Rootstock community to connect with other builders and opportunities that the Rootstock community offers. Links are in the description. Happy coding.